Hey guys, Mr. Antonucci here, and we're going to use calculus this time to prove the volume formula for a pyramid of square base. So we're going to use cross sections here, and the volume formula is 1/3 height times capital B, where H is the height and capital B is the area of the base. So again, similar to how we did this with the cone, we're going to position the pyramid with its vertex at the origin and its axis along the positive x-axis. So if you take a typical cross section like we have right here, we you will see that it's a square. Okay, so you have a square there, and then also um, the area of that square is going to be s squared if we let s represent the side length of that square. The problem is it's not in terms of x yet. We need to get it in terms of x. So if we rotate that picture and look at it head on, you can see that embedded in that pyramid is another triangle. And also, if we take where X is, you have, for the slice, you have actually two similar triangles. So again, we could set up the proportion for those two triangles relating the sides involved. So in other words, the ratio of x over s is got to be equal to the ratio of h over b. Okay. Now, if we solve this for s, you'd have to multiply both sides by s and then by the reciprocal of h over b to isolate x. So you would have s equals b over h times x. Now we have the side length of the square slice in terms of x. So we can write the formula for area instead of s squared. We can rewrite it as um, b over h times x quantity squared. I see right here, I forgot the equal sign. So this should be s equals b over h times x. Hope that wasn't too confusing. So b squared over h squared x squared. Now, again, since the area function is a continuous function of x, remember x is where we took the slice, we can get the volume by simply integrating the area function from 0 to h. So b squared over h squared x squared dx. We could factor the b squared over h squared out. Anti-differentiating x gives us x cubed over 3. So if I take all the constants together, I would have b squared over 3h squared, and then evaluate x cubed from 0 to h. So plug in h, which is h cubed, 0, which is 0 cubed, and then if we simplify this again here, the h squared and h cubed are going to cancel, leaving just h. So you would have 1/3 b squared h. Now, that b squared there represents the area of the base. So in terms of capital B, you would have 1/3 capital B H. And there you have it. Again, the area formula for a pyramid that we learned way back in geometry, proved using calculus.